Welcome back to another deep dive. Today, we are opening up a time capsule from 1985.
A very weird time capsule.
Yeah, exactly. We're going to be talking about a piece of technology that promised to revolutionize how we interact with graphics, how we create charts, and even how we educate our kids.
hmm
But before we get into the specifications or the baud rates or the software compatibility, I really have to start with something that caught my eye immediately in our source material.
Oh, I know exactly what you're going to say.
It's a warning.
It is a very specific, and I would say highly unusual warning for a computer peripheral.
Right. I mean, I've read a lot of manuals in my time. Usually you get the standard stuff. Don't use this in the bathtub. Don't expose it to direct sunlight. Don't open the case or you'll void the
The
warranty.
usual legal boilerplate.
Exactly. But the manual for today's subject, the Penman Plotter, has a safety warning regarding, quote, suspicious and aggressive cats.
It really sets the tone for the entire deep dive, doesn't it?
It absolutely does. The source material explicitly states that this device is perfectly safe, unless, of course, you have a suspicious and aggressive cat.
Yeah.
And this isn't just some, hypothetical legal text. The review we are looking at actually mentions that the specific unit being tested was pounced upon and cuffed spinning across the floor.
That is a direct quote from the review.
Right.
And it just gives you a very vivid image right off the bat. This isn't a beige box that sits quietly on a desk humming away.
No, it's not.
This is a piece of technology that actively enters the domestic battlefield.
A domestic peril. We are talking about the Penman Plotter. And the reason it's getting attacked by cats is because, unlike every other printer or plotter of its era, this thing didn't sit still.
No, it was a robot.
Right.
A graphics turtle plotter, to use the technical parlance of the mid-'80s.
A turtle cum plotter. That is quite the mouthful.
It is, but it's actually an accurate description of what they were trying to achieve.
So, let's set the scene properly for you listening. It is 1985. The Apple X is huge. The IBM PC is gaining ground. And in the UK, the BBC Micro is the absolute king of the classroom.
Right.
And peripheral manufacturers are trying to figure out what the next big thing is. Picture your living room in 1985. We're talking about an era of massive disruption of domestic harmony. You've already got arguments over TV usage.
Oh, definitely.
Like, are we watching the A-Team tonight? Or is someone tying up the television to play Manic Miner?
The classic battle.
The classic battle. And into this tense environment, someone decides that what the world really needs isn't a laser printer, and it isn't a dot matrix printer. No, what we need is a robot that crawls around on the floor.
It sounds totally absurd today, but there was a logic to it.
Okay, so help us visualize this. For everyone listening who might be picturing a standard desktop printer, wipe that image from your mind completely. What are we actually looking at when we unbox a Penman?
Well, imagine you take a standard printer and you completely deconstruct it. You remove the paper feed mechanism, the rollers, the trays, all of it.
Yeah.
You remove the heavy outer casing. You remove the metal rails that the print head usually slides back and forth on.
Got it.
You are essentially stripping the machine down to its absolute bare essentials.
So I've stripped my printer. What's left?
You are left with two distinct components. First, you have a stationary control box. They called this the garage.
The garage.
Yeah, this box sits on your desk or on the floor right next to your computer. It houses the heavy electronics, the power supply, the interface chips.
So all the brains and the brawn stay in the box.
Correct. And connected to that garage by a long, thin ribbon cable is the second part, which is the turtle.
And the turtle is the robot.
Yes. It's a small rectangular beige box. It's about 5 inches by 4 inches and maybe 2 inches deep. It has wheels, it has electric motors, and it holds the pens.
Okay.
And here is the key difference. Instead of the machine moving the paper through it, you lay the paper flat on a table or the floor, and this little robot physically drives over the paper to draw your image.
So the paper is the terrain, and the printer is an explorer.
That is a wonderful way to put it. It's a mobile robot plotter.
It sounds incredibly ambitious for 1985. I mean, robotics was still pretty primitive back then. Why build it this way? What was the core promise they were selling?
The core promise was to bridge a massive gap in the market. On one side, you had the educational market. Schools were completely obsessed with logo.
Right. The programming language with a little triangle on the screen.
Exactly. You'd type commands like forward 100, right 90, and the triangle, the turtle would draw a line.
I remember that.
Educators loved it because it taught geometry and logic. And there were physical floor turtles available at the time, but they were often just toys.
Right.
They were clumsy, they couldn't draw very accurately, they were just for show.
Okay, so that's one side, the educational toy market.
On the other side, you had serious business tools. You had flatbed plotters used by architects, engineers, and scientists.
Which were huge.
Massive, heavy precision instruments that cost thousands of pounds. They took up an entire desk.
So the Penman was trying to be the middle ground.
Precisely.
Hmm.
The pitch was that this was a device precise enough to chart your quarterly sales figures or draw an architectural floor plan, but accessible enough and fun enough to be used in a classroom to teach kids how to code.
A bridge between the playroom and the boardroom.
That was the goal. But as we often see in tech history, when you try to be everything to everyone, you sometimes end up with a product that is, well, a bit confused.
Yeah.
You end up with a precise scientific instrument that crawls around on the rug and gets attacked by the family pet.
Which brings us right back to the cat.
It always comes back to the cat.
It really does. But our mission today is to unpack all of this. We want to look at the engineering philosophy, the frankly absurd user experience, and the economic reality of this very specific 1985 gadget.
Because it really matters as a piece of history.
It does. It represents this unique evolutionary dead end in tech, the intersection of robotics, plotting, and this concept of simplicated design.
Unplicated, yes.
So let's get into that hardware. Because when you look at how this thing was built, it's actually really clever. The source material highlights a specific design philosophy that drove the development of the Penman.
Yes, they cite a maxim from Bill Lear.
The aviation guy, Lear jets.
The very same. Bill Lear was a pioneer in aviation and electronics. He also gave us the 8-track tape player, for better or worse.
Oh, wow.
Yeah. But his guiding principle for engineering was, quote, simplicate and add more lightness.
Simplicate and add more lightness. I feel like my high school English teacher is twitching somewhere just hearing that, but I get the idea.
It is grammatically tortured, sure, but from an engineering standpoint, it is absolute gold. The philosophy is that complexity is the enemy of reliability.
Right.
Every extra part you add is another point of failure. Every ounce of weight you add requires more power to move, which means bigger motors, which means more weight. It's a vicious cycle.
So simplicate means to aggressively strip away the non-essentials.
Exactly.
Yeah.
And the Penman engineers took this to heart. If you look at the Turtle, the mobile unit, it is devoid of almost anything unnecessary.
Let's break down the form factor. You said it was small.
Tiny. Like I said, 5 inches by 4. And the source notes it had a textured beige finish, which was specifically chosen to match the BBC microcomputer.
Oh, so aesthetics matter.
They definitely did.
Yeah.
But inside, that's where the simplicate philosophy really shines. It uses 2 small DC motors to move.
Just
2. And usually, when you have motors driving wheels, you need a gearbox. You need gears to step down the speed and increase the torque.
Right.
Gears add weight, they add friction, they require lubrication. The Penman, no gearboxes.
Wait, so how does the power get to the wheels?
Direct drive.
Yeah.
The shafts of the motors extend directly out of the casing, and the wheels are attached right to the shafts. The motor axle is the wheel axle.
That is bold.
It is. It reduces the part count significantly. And then think about stability. If you have a square robot, you need it to be stable on the paper. You could put 4 wheels on it, but then you need a suspension system to make sure all 4 wheels touch the ground if the floor is uneven.
Right, like a wobbly table at a restaurant. Someone's always putting a napkin under one of the legs.
Exactly. So what do they do to fix that? They use 3 wheels, the 2 drive wheels, and a 3rd unpowered nose wheel at the front.
Oh, a tricycle.
A robotic tricycle. 3 points define a plane. A 3-wheel vehicle will never wobble. It's always in contact with the surface. They removed the need for a heavy suspension just by choosing the right number of wheels. Simplicate.
That's brilliant. And the steering. How do you steer a tricycle with fixed wheels?
You use differential steering. It's the same principle used by tanks or bulldozers. If you want to go forward, you spin both motors forward at the same speed.
Yeah.
If you want to turn left, you spin the right motor forward and the left motor backward.
Or you stop the left motor and just drive the right one.
Precisely.
So it can spin in place.
It can turn on a dime. Literally. It can rotate around its own center axis. This is crucial for a drawing robot because you often need to make sharp 90-degree turns to draw a box or a graph axis.
Okay, so the robot itself is a marvel of minimalism. But we have to talk about the elephant in the room. Or rather, the umbilical cord in the room.
Ah, the ribbon cable.
Yeah. The source material says it's a 1-meter-long ribbon cable connecting the garage to the Turtle. Now, I am not an engineer, but I have used a vacuum cleaner,
Right.
And I know that if I spin around in circles, the cord gets twisted. If this robot is designed to spin in place and draw circles, isn't that cable going to turn into a knot instantly?
This was the fundamental engineering challenge of the Penman. In a modern robot, like a Roomba, you put the battery and the computer inside the robot. It's wireless.
Makes sense.
But remember, add lightness. Batteries are heavy. Computing chips in 1985 were bulky and hot. They couldn't put that stuff in the turtle, or it would be too heavy to move precisely.
So they had to use the cable.
They had to. The cable carries the power from the wall adapter, and it carries the data signals from the computer. It is the absolute lifeline. But, as you pointed out, a tethered robot that turns is a recipe for disaster.
So how did they solve it? Or did they just let it knot up and hope for the best?
They came up with a solution they called anti-tangle logic.
Anti-tangle logic. It sounds like something you'd see on a bottle of high-end conditioner.
It really does. But it's actually a brilliant brute force software solution. The robot's brain, which is back in the garage, keeps track of the robot's rotation. It counts exactly how many degrees it has turned left or right.
So it knows if it's dizzy.
It tracks its winding status. The logic dictates that the turtle is never allowed to turn more than 360 degrees in one direction without correcting itself.
Wait, so if I tell it to draw 2 circles in a row?
It draws the first circle. At this point, the cable has a full 360-degree twist in it. Now, if the next command tells it to continue turning in that direction, the robot interrupts the command.
It just stops.
It stops drawing. It lifts the pen. And right there, in the middle of your plot, it physically spins 360 degrees in the opposite direction.
It does a pirouette to unwind itself.
A maintenance pirouette. Imagine watching this. You're in a meeting, waiting for a chart. The robot is drawing a pie chart. It finishes a slice, stops, spins all the way around like a dog chasing its tail, and then calmly goes back to drawing the next slice.
That is visually hilarious. I mean, it completely shatters the illusion of a serious business machine.
It is absurd, but highly effective. The source material notes that the manual, quote, thunders that cable twisting is prevented by this logic. And the reviewer admits it works well in practice.
Thunders. I love that word choice. They were really confident in their anti-tangle logic.
They were very proud of it. But, as with all clever engineering hacks, there are edge cases where it completely breaks down.
There is always a catch.
The anti-tangle logic relies on the robot knowing its absolute orientation. It needs to know where north is, so to speak. If you are using the device in relative mode, where you just send commands like move forward 10 units or turn right 10 degrees, the robot stops tracking its absolute position.
And if it stops tracking its absolute position.
It's just tracking the cable twist.
Yeah.
The review specifically notes that in relative mode, the anti-tangle logic is disabled.
Oh, no.
So if you program it poorly, or if you just tell it to spin right 100 times,
You strangle the robot.
you literally strangle it. The cable winds up tighter and tighter until the motors stall or the cable snaps.
That puts a lot of responsibility on the user. You really have to know what you're doing.
You do. And there's another physical limitation mentioned regarding the cable. It doesn't retract, it's just a loose ribbon.
Right.
The reviewer notes that the Penman got stuck when he had pulled out an insufficient length of cable.
So it doesn't feed itself cable?
No. There's no motorized spool in the garage. That would violate the simplicate rule. So before you start a drawing, you have to manually pull out enough slack to cover the entire area you want to draw on.
It's like walking a dog that refuses to walk. You have to pull the leash out for them.
Exactly. If you don't give it enough slack, it reaches the end of its tether and just spins its wheels, grinding into the paper and ruining your drawing.
Amazing.
Oh.
Now let's talk about another sensor feature, because this one sounds like it was born out of pure, terrifying necessity. The source calls it a suicide prevention feature.
Yes. If you are using this device on the floor, you're fine. But if you're using it on a table, which many people would want, you have a serious risk. Gravity.
Right. It's a robot driving blindly. If it drives off the edge of the table.
It smashes onto the floor. Game over. Hundreds of pounds gone. To prevent this, the engineers installed 2 optical sensors underneath the chassis, looking straight down.
What are they looking for?
Contrast. The system operates on the assumption that you are drawing on white paper, and that the surface underneath the paper your desk, or a special backing sheet, is dark.
Oh, I see. So as long as the sensors see white, they assume they're safe.
Correct. White means paper. Dark means the abyss. If the sensors detect a dark surface, the robot assumes it has reached the edge of the world and performs an emergency stop.
That's actually really smart. It uses the environment itself as a boundary.
It is clever.
Hmm.
And the review mentions that upon initialization, the turtle actually uses these sensors to calibrate itself. It drives until it finds the edge of the paper, aligns itself with the corner, and sets its home position. It finds its own boundaries.
Clever as well as useful, the review says. But I imagine these sensors could be a bit, well, temperamental.
Fussy is the word used. The sensors are looking for light levels. The reviewer notes that even gentle pressure from a finger is enough to suspend operation.
Wait, why would finger pressure stop it? That doesn't make sense.
Because if you press on the robot, you might change the distance between the sensor and the paper slightly, or you might cast a shadow. If a shadow falls across the sensor, it might interpret that as darkness and think it's falling off a cliff.
Oh, wow. So imagine you are 45 minutes into a complex architectural drawing. The sun moves, a shadow stretches across the table.
And the robot beeps and freezes in an absolute panic. The review says the frustration can be considerable. It creates a situation where you need a perfect environment. A flat table, consistent lighting, high contrast background. It's a bit of a diva.
So we have a diva robot that needs a leash handler and perfect lighting, but does it actually draw well? I mean, a plotter is completely useless without pens.
This is one area where the simplicate philosophy actually saved the user some serious money. In the world of plotters back then, pens were usually proprietary. You had to buy specific ink cartridges from the manufacturer, and they were very expensive.
The classic razor and blades business model.
Exactly. Sell the printer cheap, gouge them on the ink. But Penman was designed to use standard Pentel rolling ball writer refills.
The little metal refills you could buy at any stationery shop.
The very ones you could walk down to the high street newsagent and buy a pack for a couple of pounds. The review calls this the thrifty option. It really democratized the ink supply. You weren't locked into Penman's ecosystem.
That is genuinely pro-consumer. I love that. But what if I wanted to be fancy? What if I was a professional architect and I wanted professional lines?
Well, the source notes, quote, if you are determined to have the best-dressed turtle in town, the toolhead could also accept standard Hewlett-Packard plotter pens.
Which I assume were much pricier.
Significantly.
Yeah.
But they offered better line quality, different widths, and different ink types for transparencies. So you had the choice. Cheap, everyday sketching with Pentel, or professional output with HP.
And how does the drawing mechanism actually work? Does it just drag a single pen around?
No, it's quite sophisticated for its size. The turtle holds 3 pens and a magazine at the front.
Oh, so you could have 3 colors.
Yes, or 3 different line widths, and they are front-loading. The robot can switch between them mechanically. It has a solenoid mechanism to raise and lower the active pen, so the software can tell it, select pen 1, which might be red, lower pen, draw line, raise pen, select pen 2, blue.
That's impressive for such a small unit. I mean, fitting 3 pens and the lifting mechanism in a 5x4 box.
It gets even more interesting. There is a 4th socket, a central one, and this one doesn't go up and down at all. It holds a single Pentel refill that is always in contact with the paper.
Always. What's the point of a pen that you can't lift? Wouldn't it just scribble everywhere it drives?
It would. It's designed specifically for logo tracing. Remember the educational angle we talked about?
Right.
If a kid is driving the robot around with commands, they want to see the exact path it took. This central pen leaves a permanent trace of the robot's movement. It's like a snail trail, but made of ink. It allows you to visualize the logic of your program physically on the paper.
That is a really thoughtful touch for the education market.
It really is. It shows they were deeply thinking about how this would be used in a classroom setting, not just as a printer.
Okay, so we have the hardware down. We have the motors, the sensors, the pens. Now we need to control it. This is 1985. We don't have USB. We definitely don't have Wi-Fi or Bluetooth. How do I actually talk to the Penman?
You use the RS-232 serial interface.
Just hearing RS-232 makes my palms sweat.
It triggers a trauma response in anyone who used computers in the 80s and 90s, doesn't it?
Oh, yeah.
Dip switches, parity bits, stop bits, handshake protocols. It was an absolute nightmare of configuration just to get 2 machines to say hello.
Did the Penman make this any easier, or was it standard serial port misery?
Surprisingly, yes, they tried to simplify it. It used the standard 25-pin D-plug, which was the big connector on the back of most PCs, and it had an auto-detect feature for the baud rate.
Explain baud rate for the listeners who didn't grow up with dial-up modems.
Sure. Baud rate is essentially the speed of data transmission. Usually you had to manually set the printer and the computer to perfectly match. If the printer was listening at 1200 baud and the computer was shouting at 9600 baud, you just got a page of gibberish. The penman could listen to the data coming in and automatically switch between 300, 1200, and 9600 baud.
That's a huge luxury feature for the time.
It was. The reviewer notes that the handshaking is hardwired, so interfacing is unlikely to be a problem.
Unlikely to be a problem. Famous last words in computing.
Indeed. But once you're actually connected, you aren't just clicking a print button in a menu, you are programming it. The command language is logo-like.
So you are sending literal text commands to the device.
Yes, you'd send I for initialize, H for home, D for pen down, U for pen up.
It's a very primitive language.
It's a vector language. You are describing geometry to a machine. And this brings us to the business graphics use case, which is where the reality of the device really clashes with the marketing.
Oh, I love this part. The idea that this little floor-crawling robot was a serious tool for serious business.
The pitch was this. You have your IBM PC. You are running VisiCalc or Lotus 123, the Excel of the day. You have all your quarterly sales data. You want a really sharp pie chart for the big board meeting.
Okay, I'm with you.
So you export your data to a DIF file, that's data interchange format. You run a special utility program, and then you have to set up the penman.
Paint the picture for us. I want to see this boardroom.
Imagine a boardroom. You have executives in power suits. And on the floor, because remember, you need a big flat surface to use this thing. Someone has cleared a space on the carpet. They've laid down a massive sheet of paper. They've taped it down so it doesn't slide. And there is this little beige robot in the middle of it.
And everyone's just standing around watching it.
Watching it crawl. And I do mean crawl.
How fast was it exactly?
The spec sheet says 50 millimeters per second. That's 5 centimeters a second.
That is agonizingly slow.
To draw a complex pie chart with cross-hatching and labels could take 10, 15, maybe 20 minutes easily.
So you have a room full of highly paid executives watching a robot slowly draw a circle, occasionally stopping to pirouette to untangle its own cable.
It's an incredible juxtaposition of serious intent and absurd execution. The reviewer actually defends the speed, though, which I found interesting.
How do you defend that?
He writes, the sales figures for cheap daisy wheel printers prove that people are prepared to wait for hard copy.
That is a sick burn on daisy wheel printers. Basically saying people are already used to slow, loud, obnoxious machines, so this is fine.
Basically, yeah. But compared to a professional flatbed plotter of the era, which might move at 400 or 500 millimeters per second, the Penman was an absolute tortoise.
But a cheap tortoise, right? That was the main argument.
Well, let's talk about the economics, because cheap is highly relative here. The source gives us the price breakdown in 1985 pounds sterling. The base unit cost 217 pounds plus VAT.
217. In 1985, I mean, that sounds affordable compared to thousands for a flatbed.
It sounds low to modern ears. But we have to apply the inflation filter to really grasp it. If we use a standard multiplier of about 3.9 to get us to 2026 values, that base unit is roughly 850 pounds.
850 pounds. That's a flagship smartphone today. That's a very decent laptop.
And that's just the robot. You can't use it without the cable.
Oh, right. The special RS-232 cable.
Which the review notes was sold separately for 20 pounds.
Wait, 20 pounds for a cable in 1985.
Yeah, that is a massive markup. In today's money, that is nearly 80 pounds for a single serial wire.
That is criminal. That's worse than buying premium HDMI cables at a big box electronics store today.
It was absolutely a profit center for them. Then you also need the demonstration and utility desk software, which is another 25 pounds. That's about 100 pounds today. And if you wanted the smooth laminated backing sheet to make sure the optical sensors worked reliably without shadows, that's another 12 pounds 50.
So if I want the whole package, the whole kit that actually works properly,
you are looking at a total investment of approximately 275 pounds in 1985. That is roughly 1,075 pounds in 2026 money.
Over 1,000 pounds.
For a slow, floor-crawling robot that requires you to clear your floor and write code just to make it draw a circle.
When you put it that way, the market position becomes really tricky. Who is this actually for?
Well, schools bought them because even at 1,000 pounds equivalent, it was still vastly cheaper than the 4,000-pound professional plotters. And it had that educational logo value. Kids loved watching it.
But the home user, the business user.
That was a hard sell. The review notes that software support was the ultimate Achilles heel. Most commercial software, word processors, basic graphics tools didn't have a Penman driver.
Right.
You couldn't just plug it in, hit Ctrl-P and print your letterhead. It didn't work like that.
So it was an island. It only worked with specific stuff.
Yeah, exactly.
Yeah.
The review mentions that the RoboGraphics BISTIC CAD system on the Apple II supported it. But the BBC Micro version wasn't supported yet at the time of the review.
Ouch.
The reviewer laments that without ubiquitous drivers, this high-priced package is, quote, little more than an expensive toy.
Expensive toy. That phrase just haunts this device, doesn't it? It's too expensive to be a casual toy, but not capable enough or supported enough to be a true professional tool.
Exactly. But there is one wild factor that takes it from an expensive toy to an expensive liability. And we really have to circle back to the beginning to address it fully. The environmental hazard.
The cat factor.
That cat factor. The reviewer shares this incredible personal anecdote about the condition of the specific unit he was sent for testing. He says the unit looks a little the worse for wear.
Just a little.
It's scuffed, it's scratched up.
And he explains exactly why.
He says, quite matter-of-factly, it has been pounced upon and cuffed spinning across the floor.
By his cat.
By his cat. He genuinely marvels that it's a miracle the thing still works.
I really want to dig into this because it's funny, obviously, but it's also a profound design failure when you think about it. Let's look at this from the cat's perspective for a second.
Please, get us inside the feline mind.
Okay, so you are a cat. You are the apex predator of the living room. Usually the human's electronics are totally boring. The TV just sits there, the computer sits on the desk. But suddenly, a small beige box appears on the floor.
In your prime territory.
Right in the middle of your territory. It starts making this high-pitched motor whine. It moves in unpredictable, jerky motions. Start, stop, turn. It spins around in a rapid circle. And most importantly, it is trailing a long, fluttering ribbon behind it.
The ribbon cable. It is the ultimate trigger.
It checks every single box for feline prey drive. It is a mouse because it's a small box, it's a bird because of the chirping motors, and it's a snake because of the cable, all rolled into one expensive 1,000-pound package.
It is entirely irresistible. You cannot blame the cat at all.
No, the device is practically begging to be attacked. It's a high-tech cat toy.
The reviewer is actually quite serious about the implications of this. He states that to operate the Penman, you must diffuse household tension or establish an animal-free zone.
So the system requirements on the box should be a computer, an RS-232 port, and a door that locks.
Essentially, yes. The source notes that, quote, domestic chaos is not the métier of the humble PC.
That's such a great line, métier.
It is. It perfectly captures that computers were designed to be solitary, safe, desk-bound things. They were meant to be sterile and controlled. The Penman broke that fundamental rule. It entered the physical, messy space of the living room floor, and when it did that, it entered the food chain.
It really highlights the clash between the idealized, clean vision of the future, where robots quietly serve us, and the incredibly messy reality of domestic life. The engineers at Penman designed a mathematically perfect loop of anti-tangle logic. They solved the geometry, but they totally failed to write a patch for Tabby Cat Attack.
It's a classic textbook case of engineering for the sterile lab, not for the chaotic living room.
So, let's summarize where we are. We have a 1,000-pound robot. It draws incredibly slowly, it needs custom code, it routinely gets eaten by household pets. But the ultimate question, did it actually work?
The verdict from the source is, surprisingly, very positive, assuming you accept those massive caveats. The reviewer admits that the anti-tangle logic really does work as advertised.
Wow.
And the drawings we have, images in the source material of a parrot and some complex geometric spirals. The drawings are described as crisp and accurate.
So the whole simplicate engineering philosophy actually delivered a robust, functioning machine.
It did.
Yeah.
The drawing quality was genuinely good. The mechanism was reliable as long as you remember to keep the cable slack. It did exactly what it said on the tin. But the commercial viability was doomed from the start. It was an evolutionary dead end in the tech tree.
Why? What ultimately killed it off?
A few converging things. First, as we mentioned, software support. It never really got the ubiquitous drivers needed to make it a plug-and-play device for the masses.
Right, without Word or Excel integration, you're dead in the water.
Second, the competition completely shifted. Inkjet printers were just around the corner. Laser printers were rapidly dropping in price and becoming affordable for offices.
And a laser printer is incredibly fast, it's completely quiet, and it crucially doesn't need to crawl around on the carpet.
Exactly. People quickly realized they didn't need a robot to physically draw a chart with a pen. They just needed a page with ink on it. The plotter, as a category, retreated back to the high-end architectural firms, where they stayed as massive stationary flatbed machines.
And the whole home robot idea just went dormant.
It went into deep hibernation for about 20 years.
Until the Roomba.
Exactly. And I really think the Roomba is the direct spiritual successor to the Penman.
How so? Walk me through the connection.
Well, look at the physical design. It's low to the ground. It uses differential steering, 2 drive wheels, and a caster wheel. It has optical sensors looking down to avoid falling down the stairs. It is literally the same robot chassis.
Oh my God, you're right. It's the Penman's grandchild.
The major difference is the Roomba does something every single person needs. It cleans the floor. The Penman did something only a very few people needed. Vector, plotting from a spreadsheet.
And crucially, the Roomba is wireless. There's no ribbon cable to strangle itself with.
That helps immensely.
Ugh.
And the Roomba is designed to bump into things and map a room. The Penman was designed to avoid everything and map a piece of paper.
So, looking back at the Penman from our vantage point in 2026, what is its legacy? Is it just a punchline?
I don't think it's just a joke at all. It serves as a fascinating, necessary footnote. It represents a moment in time when we genuinely weren't sure what the form factor of a computer peripheral should be. We were experimenting wildly.
Right, like why shouldn't a printer crawl around?
Exactly. It makes sense in a weird way. Paper's big, desks are small. If the printer moves instead of the paper, you can print on a sheet of paper the size of a gymnasium floor, provided you have enough ribbon cable.
Infinite scalability.
In theory, yes. But the practical reality of the cable, the slow speed, and the cats killed it. It's a stark reminder that clever engineering isn't always synonymous with successful product design. Just because you can mathematically make a robot do it doesn't mean you should.
That's incredibly well said. Before we wrap up today, I want to leave you, our listener, with a final thought to mull over. We've been laughing a lot about the 1,000-pound price tag and the utter absurdity of this device crawling around. But think about the modern maker movement today. Think about 3D printers.
Go on.
What actually is a 3D printer? It's a robot. It moves a tool head around based on precise coordinates to create something physical. It's incredibly fussy. It requires constant calibration. It fails often and makes a huge mess. And people, tech enthusiasts, happily pay hundreds, sometimes thousands of pounds for them.
And they sit and watch them.
They watch them. There are entire YouTube channels and Twitch streams of just 3D printers slowly printing plastic boats.
You're completely right. The urge to, quote, watch the beast perform, as the review put it so perfectly, is a universal human trait. We love seeing code become physical reality. There is something fundamentally magical about watching a machine slowly create art or an object right in front of your eyes.
Exactly. The Penman was just the grandfather of that specific experience. We moved from 2D drawings crawling on the floor to 3D plastic models building on a desk. But the spirit, the fascination, is exactly the same.
That is a very valid connection. It's the sheer joy of automation. Even when the automation is significantly slower than just doing it by hand, it feels like the future, even if it's a very clumsy beige version of it.
So here's my final provocative question to you, the listener. If you could buy a brand new Penman Plotter today, still in the box, for that inflation-adjusted price of 1,000 pounds, would you do it?
That is the million-dollar question, or rather, 1,000-pound question.
Would the sheer novelty of watching a beige robot crawl across your s'more and physically draw your Excel charts be worth the massive hassle of locking up the cat? Would you manually pull out the cable, carefully check the optical sensors, and dim the room lights just to see it do its anti-tangle pirouette?
I suspect for a certain type of hardcore nerd, and I absolutely count myself among them,
Yeah.
the answer is a hesitant but very distinct yes.
I think you're right. I know I would buy one just to see the cat's reaction.
Just remember the warning label.
Exactly. If you do manage to find one on an auction site, check the casing very carefully for scratches. It might have been a chew toy in a previous life.
Buyer definitely beware.
Well, that is all for this deep dive. Keep your cables untangled and always watch out for the cat. We'll see you next time.